We've learned about 6 quantities now since last Thursday, the first day of Physics 20 here. Distance, position, displacement, time, speed, and velocity. Tell me, of these 6 that are up on the board right now, which ones are scalars? Tell me one of them that's a scalar. Yep. Distance is a scalar. Give me another one that's a scalar. If there is any more, that's scalars. Yep. Speed is a scalar as well. By the way, a scalar is a quantity where magnitude matters but direction doesn't. It's a quantity that has only magnitude. Any more scalars here? Time is a scalar. There's no direction, at least not in the typical sense of direction associated with time. What about vectors? The other ones all vectors, or are there more scalars in here? Yeah, the other ones are all vectors, right? Position is a vector. Displacement, because displacement is defined as the change in position, displacement is a vector as well. And since velocity depends upon displacement, then velocity is going to be a vector as well. What are the units that we use for distance, position, and displacement? Meters, although we've seen that we've used other units as well, like kilometers and so on as well. But the standard units are going to be meters. Now, a couple days from now, when we start talking about acceleration, then it'd be critical that we do use meters. But for now, we actually can use other units as well, like kilometers. What about the standard units for time? Seconds. Although we've seen we've used hours, minutes for time, and that's okay until we start doing acceleration in a couple of days. It's okay at least. What about speed and velocity? The standard units would be meters per second, right? The big thing right now is not so much that you use the standard units of meters and seconds and meters per second, but the big thing right now is that you're consistent. In other words, if you use seconds for time, that's great, but make sure you're using meters per second for speed. If you're using kilometers per hour for speed, that's okay. But if you're doing that, make sure you're using hours for time and kilometers for distance. Does that make sense? So at some point, we're going to have to use these standard units. But for the time being, it's okay if you don't, but you got to be consistent. Seconds goes with seconds, hours goes with hours, kilometers goes with kilometers, and so on and so on and so on. All right, we've learned 2 different ways of finding displacement or distance, right? If we want to find distance, we just drop the vector sign over top of it, right? To find displacement, we can either add displacements. So I walk 5 meters to the east, yeah, and I turn around and walk 8 meters to the west. I can say 5 plus negative 8, right? 5 plus negative 8 gives me negative 3 for my displacement. I add 2 displacements together to get a total displacement. Now, the other way of finding displacement is to not add displacements, but subtract positions. So understand the difference between what I got here. Okay? I walked 5 meters and then I walked 8 meters. That's not, neither of those numbers are where I am, or neither one of them represent my location or my position. They both represented displacements. My change in position, I changed my position by 5 meters, and then I changed my position by 8 meters in the opposite direction. Those are both displacements. Now, if I said I started 5 meters north of the wall and ended 8 meters north of the wall, those aren't displacements anymore. Those are positions. Those are my locations. So in that case, I would say 8 minus 5 gives me 3. Make sense? So when you're finding displacement or distance, you can add displacements or distances, and you can subtract positions. Velocity, on the other hand, or speed, is displacement or distance over time. We have to be able to find the distance or displacement by the method that we learned last week, by adding displacements or subtracting positions. Now, we ran into this a couple of times, at least once yesterday on the worksheet. okay, for average velocity. I think it was question number 5 on the worksheet. We'll take a look at that one for sure in a few moments here. But remember that when you're looking for average velocity, this is what we do. Like if I travel at 100 kilometers per hour to Edmonton, but I stop in Red Deer for 5 minutes to go for a snack at McDonald's, I'm going 0, right? I wouldn't say my average speed to Edmonton is 50. 100 plus 0 divided by 2 is 50. I wouldn't do that, would I? I would take my total displacement on my way to Edmonton and divide it by my total time, and I would get my average speed or my average velocity. All right? So in all of those questions that you had yesterday on that worksheet, okay, for average velocity, average speed, you had to do this. V is equal to distance or displacement over the time. Not just add a velocity to another velocity and then divide by 2. That doesn't work. All right, we had 5 questions for homework. There were 6 questions on the worksheet. I asked you to do the first 5. Okay, I want to take a look at those now. We're going to take a look at question 4 and 5 on our worksheet. Number 4 says downtown Calgary is 61 kilometers north of High River, while Okotoks is 15 kilometers north of High River. You drive from Okotoks to downtown Calgary in a time of 45 minutes. What's your average velocity? What are we given here? 61 kilometers north of High River. Is that the location, or is that how far Calgary's moved? Is that the displacement? That's a position. That's a location. That's a position. That's where Calgary is. That's position. So we're going to say my initial position, sorry, Okotoks, that's a position as well. My initial position is 15 kilometers. We'll make north positive. My initial position is 15 kilometers to the north of High River. I start in Okotoks, right? I'm driving to Calgary. My final position in Calgary is 61 kilometers north of High River. So it's positive as well. And it takes a time of 45 minutes, which, I don't know about you, but I think I want to convert that to hours. 45 divided by 60, because there's 60 minutes in an hour, gives me 0.75 hours. I want to find the average velocity. Now, velocity is displacement divided by time. Displacement is, am I going to add these numbers, 15 and 61, or am I going to subtract them? Subtract positions. Okay, these numbers both represent where something is at 2 different times. In order to get the displacement, we subtract those numbers. So 61 minus 15 over the time of, we'll say 0.75 hours. That's going to give me 46 kilometers over 0.75 hours, which gives me a value of, that works out to be 61 kilometers per hour. Notice, I don't really have to put the positive there, but I did because I'm reminding myself that this is velocity, which is a vector, which has a direction associated with it, and I defined north as positive. The alternative is I could write the word north in there, 61 kilometers per hour to the north. Yep. Now, let me change this question around just a tiny little bit. Let's say we said Okotoks is 15 kilometers north of High River. De Winton is 25 kilometers north of High River. And Calgary is 61 kilometers north of High River. Everything else is the same. But we add De Winton in there. Okay, De Winton is, what did I say, 25 kilometers north of High River. Same amount of time. We're driving from Okotoks to High River, Okotoks to Calgary, and still, but we're going past Winton. How does that change the way I solve this question? It doesn't. It doesn't. This is a position, but this is my, well, remember what we called it the other day, my middle position? If I got positions, all I really want is my final and my initial, right? My final is Calgary, because that's where I end up. My initial is Okotoks, because that's where I start. I don't really care where I went through. I went through to Winton, who cares? If I went through, well, there's no other really towns, I guess, between High River, Alderside. Hey, who cares, right? If I start in Okotoks, I go to Calgary, final position minus initial position, regardless if I'm given other positions in the mix as well. Okay, let's take a look at number 5. 5 says a jogger runs 5 kilometers north in 25 minutes, stops for a break for 10 minutes, then runs 10 kilometers south in 53 minutes. I'm just going to circle this because I got this feeling if I don't, I'm going to forget that there's a south in there, and I'm going to mess up on the signs, the positives and negatives here. Just a little reminder to myself. We want to find the jogger's average speed and the jogger's average velocity here. What do I have? 5 kilometers north, what is that? Is that a distance? Sorry, is that a displacement? Or is that a position? Is that like where the jogger is? Or how much the jogger's location has changed? That's displacement, right? The jogger ran 5 kilometers. Not the jogger is 5 kilometers north. The jogger ran 5 kilometers north. That's displacement. We're going to call that my first displacement. Now, my second displacement, I'm going to say is negative. Actually, yeah, let's call that D3, actually. Do you know why I'm calling it D3 instead of D2? Anybody know why I'm calling that D3? It doesn't really matter. You want to call it D2, go ahead. Does anybody know why I'm calling it D3? Yeah, really D2 is 0, right? My displacement during the break is 0. So I do have a second displacement here, but it's 0 kilometers. Now, time 1 is 25 minutes. Time 2 is 10 minutes. Time 3 is 53 minutes. Does that make sense? Now, here's what some people want to do. Here's what a lot of people want to do in this question. Okay, don't write this down because it's wrong. But here's what people want to do. People want to say, oh, look, V equals D over T. V equals, not that one. V equals D over T for this one. Get 2 different velocities, one for the first interval, one for the third. Get 2 different velocities, add them up and divide by 2. That's average velocity, isn't it? No, it isn't. No, the time intervals are completely different here. The average velocity is not just add these 2 up and divide by 2. What we've got to do is say velocity, well, actually speed first, right? Speed is equal to distance over time. The total distance I traveled is what? 15 kilometers. Why don't I put the negative in there for that? 5 plus negative 10? Why am I just saying 5 plus 10? Distance, somebody said it? Speed's a scalar, distance is a scalar, so I don't pay any attention to the negative there. 5 plus 10 is 15. Divide it by the time of, what is this? 98 minutes? 88 minutes? Which is 1.46 hours. Add them up and then divide by 60 to get hours. So 15 divided by 1.46 gives me an average speed of, what is that, 10.227, 10 kilometers per hour. There's my average speed. How would I get my average velocity? Displacement over time. It's a distance over time. It's displacement over time. What's my displacement? Yeah, I'm still going to add these up, right? 5 plus negative 10. Like, I know some of you are thinking, well, that's subtracting. No, it's not. It's like subtracting, but it's still adding. When we have displacements, we add displacements. We have positions, we subtract them. We have displacements, we add them. 5 plus negative 10. Why the negative there, though? Because it's south. And since we're dealing with velocity and displacement, which are vectors, we have to take that into account. My time interval here is still 1.46 hours. Why do we not make this a negative 53 minutes? Like it's going south, right? Why isn't that negative 53? Because what? Yeah, time's a scalar. Direction doesn't matter. So it doesn't matter that it's south. The time is still positive. The displacement's negative, but the time is positive. Okay, so this gives us negative 5 divided by 1.46, which gives us an answer of negative 3.4 kilometers per hour. What does that negative mean in my final answer? South. I really should have defined north as positive up here somewhere. Negative means south, all right? The alternative way to writing this is, instead of writing negative 3.4, you could have said positive 3.4 to the and then mention the word south. Positive 3.4 south. Does that make sense? You guys doing okay there? Okay, I'm going to give you number 6 here in a bit, but I'm looking out there at your faces, and I think you could use a little bit more practice. So I'm going to give you another worksheet here. Ask you to hold off on doing question number 6 right now, and then we'll come back to that one a little bit later on. Taking a look at question number 6 on last night's worksheet. The question says, a car travels 90 kilometers per hour to the east for 10 minutes, and then 100 kilometers per hour to the west for 30 minutes. What's the average speed? What's the average velocity? Here's what people want to do. Just like in question number 5, people want to say, oh, 90 plus 100 divided by 2. But that's wrong. You can't do that. If I travel at 100 kilometers per hour for 5 hours, and then I stop and go 0 kilometers per hour for 2 minutes, my average speed isn't 50 kilometers an hour. Right? My average speed is almost 100 kilometers per hour. We can't just add them up and divide by 2. Rather, whenever we're solving for average speed, we've got to use the equation distance over time. And when we're finding average velocity, we've got to use the equation displacement divided by time. Every time, including question number 6 here, including number 5 on this worksheet, and including questions 4 and 5 on the other worksheet. Now, what's my distance traveled? I don't know. So I've got to figure that out. There are 2 intervals here, 2 things happening here. Okay, we're going at 90 for 10 minutes, and then we're going at 100 for 30 minutes. I'm going to say d is equal to v times t. Remember, that's the rearranged form. V equals delta d over delta t. I can rearrange it, get d is equal to v times t. In the first stage, my velocity is 90 kilometers per hour. And my time is 10 minutes. What is that in hours? 0.1667, I think. Is that right? Oh, I did it in meters per second, actually, on my answer key. Oh, well. We'll stick with this. 0.1667 hours. So let's figure that out. Does anybody have that? Because I didn't do it this way on my answer key. What is it? 0.667 hours? No, I don't think so. 10 minutes? We multiply those together, we get 15 kilometers. Okay, so I traveled at 90 for 10 minutes, and I went 15 kilometers. And then, in the second stage, what did I do in the second stage? Well, I traveled at a velocity of negative 100 kilometers per hour. Right, negative because it's to the west, times 30 minutes, that's 0.500 hours.
Are we trying to find speed or velocity?
Well, we want speed and velocity. So I'm finding displacement right now, but to find speed I need distance, but distance is easy once we have displacement there. This gives me negative 50 kilometers. Okay, let's get speed now. Distance over time. What was my distance traveled here? My total distance traveled, 65. 15 plus 50 gives me 65. Over my time interval of 40 minutes, which is 0.667 hours. 65 divided by 0.667, what does that work out to be? 97.5? 98? Hey, notice this, that my average speed is closer to 100 than it is to 90? How come? Right. I'm traveling at 100 kilometers per hour for 30 minutes. I'm only traveling at 90 kilometers per hour for 10 minutes. Now, what about displacement down here? Velocity, which relies on displacement. My displacement would be, what, 15 kilometers that we got right there plus negative 50? Not subtracting, we're adding, but we're adding a negative value. That gives me negative 35. Divided by the time, well, the time is still 0.667 hours. We got negative 35 divided by 0.667. 52. Negative 52 kilometers per hour. So just a couple of things to watch out for here. Firstly, you're looking for average speed, average velocity. You've got to use these equations. Don't try to take some little shortcut, just adding them up and divide by 2. It doesn't work. The only exception to that, the only time it actually would work would be when? Can anybody tell me when it would work to add them up and divide by 2? I don't want you to do this, but there is one specific situation where that would work. For the same time. For the same time. If I went 90 kilometers per hour for an hour, and then 100 kilometers per hour for an hour, then I could technically add them up and divide by 2. But that doesn't usually happen, does it? Usually it's 2 different times, so get used to this. Okay, use V equals delta D over delta T, always. And then, well, then you gotta, if you don't already have it, you gotta get the distance and displacement, like we did over here. Now, question number 5, we already had the distance and displacement given to us. Here, same question, except that we had to find the distance and displacement before we subbed it into V equals D over T.